Thank you very much for being here. This is the first webinar that we are organizing at Planeto. I am Giulia, and I'm the Vice President of Business Operations here at Planeto. And I'm here with Jonathan, who's the CTO of Planeto and also co-founder. So I'll just first introduce who we are. If you don't know us, we are a spin-off of the University of Geneva. We are powered by energy engineers like Jonathan here, from EPFL, ETH, and Unige. The whole Planeto experience and the main product that Jonathan will present to you is the product of collectively 20 years of research and development at the University of Geneva. And the project of Planeto was actually awarded different prizes across Switzerland, both from the entrepreneurial side, but also for the research and development side. For example, by VentureKick and InnoSwiss last year. So why we created Planeto and why the main tool that we created it's now available to you, and we make sure it was available to you as soon as possible, is that now energy engineers face a challenge. More and more district heating and cooling networks need to be built and also designed if we want to meet energy targets in Europe and also outside Europe. One of the main issues that we see and the energy engineers are facing is that each network takes months to plan. And also, if you don't plan it with the right tools, and if you have to do changes along the way, this will create challenges like an increased costs and also potential delays in the project. Tools that are now available also do not really account for the complexity of new district heating, new types of district heating networks. For example, if we more and more we need to include renewable energies in our networks, and this creates really challenges and increases the complexity of this project, making it very hard to plan and actually impossible to plan in some cases with normal tools. So energy engineers are now really under pressure to deliver new district heating networks with stronger focus on renewable energies, and they're missing the technology to do this efficiently. And this is where Planeto came in, and this is where TESSA, our flagship software, can really help. So I give the word now to Jonathan for introducing to you what TESSA can do to you and why we created it and how this puts together all the knowledge from more than 15 years of energy work.
Thank you, Giulia. Our software, TESSA, the Thermal Energy Systems Simulation Assistant, combines, as Giulia mentioned, many years of work across different specific topics that are relevant to the development of urban energy systems, of district heating and cooling systems. So we have automation of the thermal network layouts and simulations of thermal flows. We have AI-based models for predicting energy demand in buildings today and in the future, also driven by climate change. So there's the climate science behind to understand how heating and cooling demands are going to change over the next decades. All of this powered by large geospatial and building data sets, climate data sets, everything needed for powering all of these algorithms. These are the four things that we integrated into our online software platform so that engineers at energy utilities, at engineering consultants can deliver these projects faster, better, with higher proportions of renewable energy to decarbonize the built environment and to enhance energy security. We deliver this in our TESSA platform with three main topics, which is allowing flexible scenario analysis. So that means being able to do many scenarios, make them very quickly, make them very easily, adapt them with, for example, different energy sources, different base assumptions to really support better decision making. We can then really help respond to the customer needs, so really the end users and municipalities, which are the ultimate client of utilities and consultants, by, for example, adapting to local conditions, integrating local renewable energy sources or local excess heat or waste heat from industry. And for our clients, so our consultants and so on, to be able to help you win those tenders, help you win those projects, make sure they're actually successful and that they carry through from the first feasibility stages, really all the way through design and implementation. And of course, in this process, we maximize productivity. We turn what can take weeks and months of data collection, of design, and compress that into a few hours and just a few clicks. We can automate complicated and fiddly topics like dimensioning pipe sizes and optimizing their layout. And we allow to use the same tools from really the blank slate from the pre-feasibility stage all the way through design engineering phases with a single tool that carries all of the data and allows all of the detailed work that needs to be done. And finally, we have some really nice collaboration tools built in because we know these are complex, multi-stakeholder projects. So being able to have different companies, different individuals work on the same project in real time is something you can do with our TESSA online platform. To give you an idea of some of the things we can do, I want to present now a few case studies, followed by a short live demo. So we have 3 reference cases here. I present first the ones in Switzerland that we worked very closely actually with Swiss engineers and the Swiss R&D environment to really bring the value of TESSA into these projects in Canvaux, in Schaffhausen, and in Haute-Saône, each time with different clients and partners in each project, Strom, Symphony, and GeoImpact in these cases. The first project I'd like to present, a project I particularly like in Canvaux, which is a UNESCO World Heritage Site situated in the vineyards above Geneva Lake. A very challenging site, of course, a historically sensitive site, one that was fully dependent on fossil fuel. The goal with this project that we were able to support with our TESSA platform was to develop a 5th generation network providing heating and cooling. With TESSA, we were able to evaluate how the cooling demands in particular and the heating demands would evolve in this area. So it's a very exposed area to the sun. So we see very large increases in cooling demand. That's something that TESSA was able to project, and it was actually a new element in this project. And also to then optimize the energy resources, in this case, a shallow geothermal field, thanks to simulating seasonal and short and long-term regeneration of the heat storage. This was a project we did together with Strom. So we delivered the TESSA software and platform to the engineering company Strom, supported by the Swiss Federal Office of Energy, because this was a pilot and demonstration. And the report, the full report of this is available on the Swiss admin Aramis site. So that's the site that holds all of the reports of publicly funded projects under the title Réseau énergie avec sources primaires décentralisées. You are able to find also this link on request. Some of the key results from this project was, well, thanks to TESSA, it was able to design a single loop network for 80 buildings. Thanks to being able to simulate the heating and cooling demand over time, was actually demonstrated a 50% reduction in the number of geothermal wells that had to be dug, which was significant cost saving, as well as delivering an additional energy service, which is cooling, which we were able to demonstrate, thanks to TESSA, was going to increase significantly. And we were able to demonstrate this to the local authority and make them aware that this was an important energy need that they would have in the future. And that's the system that we proposed could meet this need. The second topic case study I want to present was in Haute-Saône. So this was more of a high-level strategic energy concept. Haute-Saône is quite a mixed community, mixed municipality with some urban and rural areas that they were looking to reduce their CO2 emissions to meet. Actually, they were seeking an energy label, the Energy Cities Green Energy Label. This where we delivered TESSA in collaboration with our friends at GeoImpact to deliver investment costs, energy cost projections for an energy transformation for the communities that would use district heating as designed by our TESSA platform. So the key results of this, we were using TESSA. They were able to identify just 5 building clusters that represented 80% of the emissions across the whole municipality. And with just 184 buildings identified, they could design a ground source heat distribution system with a wood pellet peaker plant. So that really used very nicely the local resources they had, which was space for some geothermal base load and quite a lot of managed forested area, which could provide green wood, so renewable energy sources. And this resulted in them being able to demonstrate a reduction of 10 times the CO2, so going from 290 to 26 grams CO2 per kilowatt hour, thanks to these designs, and do so very quickly and very accessibly. The last case study I wanted to mention was something where we worked with our very good friends at Symphony for the energy utility of Schaffhausen. Symphony do multi-energy optimizations, so that means across electricity, heat, and other energy vectors, and are able to optimize for an area what could be the best resources. And in synergy with TESSA, we were able to demonstrate an automated optimization pipeline for the decarbonization of the urban energy supply and its distribution. So the key results was really automating this whole pipeline, so optimizing which kind of energy resources should be used, and then thanks to TESSA, optimizing the distribution of the creation of the thermal distribution network, the simulation of this network, which is of course relatively complicated, having multiple heat sources, solar thermal, wood, various heat pump sources. So that's a multi-source meshed network that we were able to simulate in TESSA and have a fully automated optimization pipeline with a pilot in one of these areas with about 5 kilometers of pipeline. What are some of the key features of TESSA that make this possible? Well, we see a few things that are, most interesting in the end for our current users and for our current clients. The scale and the speed that we're able to deliver. So automating a lot of this energy demand modeling, automating with generative AI the design of the distribution network, providing data which is plug and play data for the whole of Switzerland today. We have on our roadmap for the second half of 25 being able to deliver the same kind of data for the rest of Europe. And of course, being able to have collaborative editing, import of any kinds of data source, export of all the results, making it very much avoiding this kind of trap of being in a black box, being able to import, export whatever data is needed. That means that what we can do is go then into the second point, which is really reach the engineering detail that is needed to make these projects go ahead. So rather than just stopping at a general high-level plan, we can really take our automated dimensioning, for example, apply fluid and mass flow solvers, allow the user to do really detailed parameter editing, so get really into the weeds of how to design the real project rather than just do a general feasibility. And we do this really by taking all of this automation we have, delivering it to you, but also delivering all of the tools you need to really get into the details and edit manually or import other data sources to challenge maybe the assumptions that are in the tool. And this really has a goal of ultimately the project success, being able to follow projects as they grow over the time, as they become more complicated, as they have maybe multiple stages, allowing to do financial modeling, cash flow analysis, compare different scenarios, and so on. To illustrate some of this concretely, I mean, when I said scale, of course, some of the case studies you saw were relatively small with a couple of hundred buildings. TESSA has absolutely no problem dealing with much, much larger scale. Here we have an illustration in Switzerland with about 2,500 buildings. So we can really, with TESSA, go up to whatever scale is needed and keep all of these fast automation features. We can have really detailed dimensioning, detailed editing of key parameters. So for example, detailed editing of pipes. We can automate the calculation of the optimal pipe dimension, but they can also be set precisely and then give you full detailed data output, like here, for example, giving power and the volumetric flow rate. So really getting into those key engineering parameters which are needed to validate designs going towards construction. Following projects and following how they grow, that's really a very important use case, very important in the real implementation of such projects. Here you can see an example starting with just a selection of buildings, connecting up the least efficient buildings in this particular area as a first stage, and then moving into developing a second stage, extending to the rest of the buildings in the network, in the village. This is really what allows to plan over a long term how your projects are going to grow. And actually, we support many different kinds of workflow. So you can go from an existing network, extending it to more places, or you can have a long-term plan of where that you want to go with your total network, and then see which sections of it you should build first. We are very, very flexible in the kind of workflows you build around this. As I mentioned also, future energy demand. This is really important for understanding how and making sure these projects are really successful. In this case, we're able with TESSA to apply a future energy demand prediction to this same village actually. It's a bit small, but when you zoom in, you can see some really interesting things that start to happen. The least efficient buildings that maybe you connected first to provide with a district heating to reduce carbon, actually in the future will become the most efficient buildings because they will be renovated in priority. This, of course, has a really important impacts on the dimensioning of the network and, of course, on the business model of the amount of energy that's supplied. And you can see here in the bottom with this little blue curve that starts to pop up. In a couple of decades, you start to see cooling demand become much more significant than it is today. And finally, of course, we can't forget the business model. With TESSA, you can very easily do investment calculations, operational cost calculations, understand what impact that's going to have on projected energy prices, build a cash flow model using your predicted sales prices to then get, of course, the classic KPIs, your heat cell revenues, your net present values, payback periods, all of the key financial indicators that flow from the design of the system. In this case, for example, we actually have quite an attractive payback period of 2 years. So this is the kind of very strong arguments that can be made towards decision makers and energy utilities and so on. So now I'd like to pass over to a brief demo, just to give you a flavor of what we can do. We have, of course, many capabilities, as I'm sure you've seen. So we also invite you, of course, if any of this thing entices you, to please contact us, and we can give you much more in-depth demo that you can, based on really your specific needs. So now I'm just going to give you a brief overview. Using actually the same village you've seen in some of these examples, Satigny near Geneva, very nice place up in the vineyards. I've already drawn a selection for it, so I can very quickly, with my toolbox, create a district based on the selection. What's actually happening here is we have a live simulation of the energy demands based on building characteristics. So now we have color coded based on the heat demand intensity, all of the buildings. We have a full simulation, including, for example, heat demand load curves based on climate and so on. I can configure equally quickly a utility network, a thermal network with many kind of parameters. In this case, we can leave all of the defaults that are there, which is a classic thread generation system with an 80-degree supply temperature. Add an energy center, move it to where I think could be a good spot for it. Configure its characteristics, like adding what kind of heat sources. Configure the heat source. Let's just make a ground source heat pump for the sake of the example. Now I have a full configuration of the first, let's say, scenario of how we would build this network. I can then create a layout for it. And we can see really in a few seconds, we've gone from a completely blank slate to a energy demand prediction, a thermal network configuration, and a layout of where all the pipes are going to go. I can also then start to dimension my pipes using our automated pipe dimensioning tool. All of these things, in this case, I'm just letting the TESSA set automatically, but everything can then be edited manually. Layouts, dimensions, all of these things can be then set by hand or modified or applying other, for example, optimization algorithms. And finally, I'm just going to simulate the operation. And this now allows to, for example, if I select a pipe, I see I have the full detail of the output of our tool for this given pipe, where I have the nominal diameter, I know its length, I know how much heat it's going to transport, I know the peak fluid velocity, and I have a cost estimate in this case based on the assumptions. So what we've seen there is really in just a couple of minutes going from a blank slate to a very complete first draft with engineering parameters, physical dimensioning, cost estimates that can then be used to go to the next stage of the project. And of course, in the next stage of the project, we can come back to this case, do more editing, get into much more detail, and respond to maybe comments or changes to the brief in order to really find the project that's going to fit best for this local area and that's going to meet the local requirements. Just to give you an idea, we also have then, of course, a very complete summary report that produces a huge amount of data that can then be used for your reports exactly to provide a strong argument for design. We have very large amounts of data about buildings, about energy carriers, about the characteristics of the district network, about costs, and all the other kinds of KPIs. So with that, I'd like to thank you for your attention of the demo. I again invite you to contact us for any more details. We can, of course, give you a much more in-depth demo. We can discuss to understand your specific needs and which of our various calculation modules and tools you would like to have, and give you access to a demonstration free trial if you do so wish. So with that, thank you very much, and
thank you very much, everyone. Hope to hear from you soon.